Now, then the question is, okay, this helps you find those queries. How do you optimize them? And that is using the tool in Postgres called Explain. And again, I'm sure other databases have something similar.
Yep.
It basically tells you what plan the planner has decided to execute. So basically, you just have your statement. It could be an insert statement, delete statement, update statement, select statement, and you just put explain in front of it, and it tells you what plan it intends to do. And a lot of times what I like to do, at least with select statements, is do an explain analyze, because then it exactly runs that query and gives you a report on the timing. So it does show you the plan and then how long it took to execute that plan, each individual component. And it looks a bit like this. So for example, for something very simple where, this is select all from a table where the unique is less than 7,000, it'll tell you, okay, my query plan, I'm going to do a sequential scan on that table. So basically it's going to look at the table and go through every single one. But if you add an index, the plan can change. So now the planner will know, okay, there's an index now. So now I can now do a bitmap index scan on this table. So I don't have to just go through every value of the table. I can just look at an index, and a lot of times you get much better performance. So you can look at the cost estimate goes from 483 in this case to 229 in this case. So it gives you better performance.
And this is a place that I start a lot when I'm investigating long-running queries, because this is one of the easiest ways to find missing indexes. Because if you start seeing a bunch of table scans in your explains, that's when you need to start thinking, well, why isn't it using an index? Either A, I don't have one, or what sometimes is the case is the index is actually slower than just table scan because the data isn't distributed enough. So for instance, like you almost never index Boolean fields because there's not enough distribution of data for the index to be effective. But that can happen in any type of field. If you've got like let's say you have a settings field that only has 3 possible values.
Or a status is what I see a lot.
Yeah.
Like a status only has predefined. And that, that is there's a term for that, cardinality. So there's low cardinality for that particular column.
But
so an index is not going to be as efficient on that.
Right. But going through the explain, when you start seeing table scans, that's where you want to concentrate first and say, okay, am I missing an index, or is this a cardinality issue?
Yeah, and generally what I like to do, because a lot of times the queries got a lot more complex, is that I look through and say, okay, so the total cost of this is 713. And well, is there, I guess I'm looking for something a little bit more complex. So here they did an explain analyze of this, and we'll just look at the timing here. So approximately 7 milliseconds for this whole thing. But then I try to find, okay, what area is taking the most time? This is super fast. That's super fast. Starting to get a little slow here. And here you're doing a sequential scan on the table. So, okay. So like you're saying, all right, so I probably need an index on this table to speed things up.
Right. Now, deciding whether you need a simple index or a compound index, or that's a bigger discussion. There's whole courses on how you pick an index for your structure. But in most cases, if you see those table scans, you likely need an index. That's the most common case. Unless it's a very low cardinality field, like a Boolean or a setting or something.
Yeah, and it looks like they, looking through this example, and I actually didn't look at this in depth, but they've whittled down the performance of this, adding additional things, and now you can see it's doing a bitmap index scan. So apparently they added an index through here, and they got execution, sub 1 millisecond. Right. So it's basically you look and see where the bottleneck is in the query plan, and you address it, typically through indexes, or you rethink how you're doing the query, or something else. Or again, going back to the statistics, I've seen the case where something's just not working. And if we ramp up the statistics for that table, again, this with larger systems or large amount of data, gets where some impact can come in, you could get a better query plan out of it.
Yep.
Okay. If you like this clip and want to watch another one, you can click right here, or if you want to watch the full video, you can click here.